Let's say that traditionally a blockchain is a chain of blocks that where every block contains the references or reference all the transactions that being performed within that block. This leads to a couple of problems, let's say. One is a scalability problem, because obviously as the blockchain grows, we also keep saving and storing all the transactions history with that. And the second is more of let's say network complexity issue, because to tackle that problem we need to put in place some mechanics that allow us to erase some data while keeping others in a way that we don't break the mathematics that keeps the blockchain running. But in our solution we thought about splitting the blocks into two different types of blocks. The first type just includes a small set of transactions, like the metadata of snapshots we're gonna take at a certain point in time. The other block will keep all the other transactions, like the user-to-user payment transactions or messages transactions, in a way that where we create a snapshot, which is let's say recorded on the first block, after this time we can erase all the previous blocks from the other let's say block data. So in a way that the first block type will be used to synchronize data on the second block type and keep the data consistency.
What this new approach to blockchain does is in fact a way to reach a certain point in time faster. We know that, for example, installing a new Bitcoin nodes required to download 200 gigabytes of data, which requires 2 weeks of work. And each node, before is able to participate and validate transaction, needed to rebuild and go throughout all the transaction from the beginning of time. And this becomes an issue as time goes by and the blockchain bloat. So having two different kinds of block create two starting points, because for the integrity of the blockchain it's very important to calculate the mathematics from the 0 to today in order to see that there is a chain in place. So what we did, creating special blocks that we call mega blocks, is to create a sort of shortcut, a fast time travel to go from the 0 to the closest point in time respect of today, where there is a large snapshot with the state of the blockchain as that day. And then from the day to actual today, there will be the regular blocks that are downloaded to bring each node to the current state of the blockchain. This makes something like a large blockchain like Bitcoin able to download in 10 minutes, because we start and skip all the steps until we get the most current snapshot that has been taken, and only download that through the peer-to-peer network, as much as I download a movie from a torrent per se, so that my node is able to see the situation of up to a month ago and rebuild only the last few days of blockchain.
By having two blocks, we can have two types of block have different responsibility. For example, one block can work as a normal blockchain. It will create blocks for every period of time, and it will be really long. In order for us to start joining the network, we will have to download all of them. That will take a long time. So in order to get a shorter time, we will have another block that will try to take a checkpoint for the blockchain in a certain period of height. So at a certain height of the blockchain, we will take a snapshot which will represent the necessary data, not all of them, the necessary data to run the blockchain. So when we run the blockchain, we don't download all of the blocks from the very beginning. So we download the other type of blocks where we have the checkpoints until the last checkpoints, and then we know where we should download the blocks from. That will save us a lot of time.